Hi, good afternoon. It's Dean from maverickstar Observatory. Continuing with the investigation as to whether there is a link between Earth's magnetic highs and low intensities with regards to volcanic activity. Haven't managed to speak to a oceanographer or a underwater or deep water volcano expert or volcanism expert, but what I have found is this chart which does show us the underwater or deep volcanism points around our Earth, and as you can see, and it shouldn't come as a surprise to you, most of them are on the Eastern Pacific Rise and the Mid-Atlantic Ridge, and then we've got the Western Pacific ridges as well. Our world is made up of a lot of these tectonic plates, and we have convergent, subductive and divergent plate zones. For instance, Mid-Atlantic Ridge is a divergent plate zone where it is being pushed equally apart on both sides, and that's why over millions of years Africa have separated from South America and North America. If we went back in time, like I said, all these continents would be part of a supercontinent. Off the top of my head, can't remember, maybe it was Pandria or Gondwana, can't remember the name of the actual supercontinent back, very far back, where it was all one, but if you were that interested, I'm sure you could do a bit of research and find out. Like I say, it's not conclusive. Looking at this, comparing it with land volcanoes, one thing that comes to mind is that land volcanoes around the equatorial region of our planet seems to be more common than when we go underwater. We seem to find that these underwater volcanoes go right up to and over the Arctic Circle. So, you know, there is a difference between the two for some reason, whether that is down to, you know, the coolness of the ocean cooling that ridge down, maybe causing it to crack with the underlying heat. I don't know. Anyone might know more about that than me. What I'm trying to find is something that links magnetism and the shifting of high intensity and low intensity with the volcano activity. And the reason for that is we know by studying on Mars, when the volcanic activity ceased to exist, it was probably an indication of some solidification in the core of Mars, and as a result Mars lost its magnetosphere, which it used to at one point enjoy, which in turn kept water in its atmosphere and on its surface. And I've pointed this out many times. We know it had water because of the erosion marks that would have took tens of thousands of years to leave their scars in the you know, the terraform that we see today with modern spacecraft that have mapped it. So, you know, that's why I'm interested in now going back to volcanism and to see if there's anything that we can draw a line with, but it is very difficult. All I will say is that where there seems to be less volcanic activity, be it on land or underwater, there seems to be increase both in high intensity and mid to low intensity. I'm talking about magnetic intensity. The Mid-Atlantic Ridge is a weird anomaly, and I suppose that's why it's, you know, gained so much scientific interest over the years. One thing I can say is that there is on the central, or you know, around the equatorial region of the Mid-Atlantic Ridge, you can see 4 active vents there, or volcanoes. And if you look on the magnetic chart to the right, you will see that it seems to be a region which has on one side more intensity than the other. So on the side of Africa, on those ridges under the Mid-Atlantic Ridge where the volcanoes are, there seems to be more intensity. It slightly goes into that pale blue, but the darker blue is an indication of less intensity. So we're probably going from, you know, on one side of the ridge going towards South America, we're probably looking at 20 microteslas, but on the other side we could be as much as 30 to 35 microteslas. And I'm just wondering whether it is the fact that not only is there those 4 active underwater volcanoes, but when we look at land, there's also a clump within that region of land volcanoes. I'll just switch over so you can get a clearer picture as to what I'm seeing. So as you can see on land, you can see those three in Africa, volcanoes, and of course where you look on the intensity, it seems to be in the 30 to 35 microtesla range. And of course we have the mid-Atlantic ridge, which you can't see on this map, but they would be around there, and it is just on this side going towards South America that we get this South Atlantic anomaly, or this region where we have on the planet with the lowest magnetic intensity in a range of about 20 to 22 microteslas or thereabouts. So it's not very conclusive. If we go back onto the other chart, which shows us the underwater active volcanoes, we can probably suggest that where the intensity is less, I mean, you can clearly see over the northern hemisphere there isn't a lot of volcanic activity on land. On the underwater chart, that does show obviously going straight over Iceland and Greenland, volcanic activity, because of the mid-Atlantic ridge actually goes over that direction there. But it seems where there isn't any activity is where you get the highest regions of magnetism. I don't think that that's by any coincidence, but we still haven't found out why that is the case. So guys, looking back at the ridge network of volcanoes around our world, I've actually, in those circles, as you can see, added the the main plumage of intensity and also the microteslas associated with that intensity in that region. You can see the blue circles are that of the splitting apart South Atlantic anomaly. It has been widely accepted now by NASA that is what is taking place down there in that region. The South Atlantic anomaly is splitting, and I'm just wondering if it's because of the inferred vents, and there is no current information on those inferred vents as to whether they are active or dormant at the moment, or inactive. But just looking at what we see all these intensities in the high range from 55 to 60 over Canada and Russia, and then we've got the Australian one, all in vicinities where there isn't any direct volcanic activity. And I don't think that is by coincidence. And if those inferred vents on the South Atlantic anomaly are active now, because they are, when this chart was made, inferred, which means there wasn't any conclusive evidence to say either inactive or active, then if that is becoming an active region of the South Atlantic anomaly, and the ridge is becoming active in those inferred markers, then it could be the reason why the South Atlantic anomaly is splitting. I wonder whether anyone else has made this conclusion. I mean, it would be unusual to get volcanologists interested in geomagnetics, other than the fact that when you look back in the history of volcanic vents on Earth, they are good recorders of the magnetite as it solidified at that time. And we have on the website, on our channel, on our website, Pole Shift News, a good video done by Nova that actually shows you them coring samples out of lava flow, and from one point to another, it is suggested that during a not a full magnetic reversal, but an excursion where it flipped for a short period of time and then went back over, that during that point in time they'd managed to record in that volcanic solidified rock. So it'd be very difficult, I presume, to find somebody that is interested in volcanism and magnetism to draw the same conclusion. So you might be hearing this for the very first time and seeing this for the very first time. And if that is the case, then I just think that it warrants more investigation. Now, as a small observatory, we certainly don't have the money to charter a vessel to go out to the South Atlantic ridge and drop a submersible down there. You'd be talking millions of pounds to do that, and months of work. So it really is difficult as to where we take this from this point, other than just logically assuming with the evidence that we've got that that is the case. Again, right over on the Arctic Circle at the centre, you can see that there's a lot of inferred vents where the information is not clearly known whether they're active or not. But I will say that the magnetic north dipole has passed over that ridge already, and he's heading towards that region in central Russia, just below the Arctic Circle. That would be great if we could get one of our magnetometers there, and of course you know why we want to get one in South America, in Brazil, because this is one of the two regions where we don't have magnetometers at the moment. We do have on both coastlines of East and West Australia, we do now have in Canada, we do have one in Arizona, but really we need to get those out into South America and into Russia at some point in the future. And we also, I think, for the benefit of this, trying to resolve why the magnetic anomaly is parting, it would be great if we could find out whether those inferred vents are actually active or inactive. If they are starting to become active, then I wouldn't mind betting that the reason for that is the Southern anomaly is splitting, is because they're becoming active. And the reason why I say that is because all these intensities, be it high or low, are separated by volcanoes all around them, and they seem to be in vicinities where there are no volcanic eruptions. Again, in its own right, mid-Atlantic ridges and mid-Atlantic volcano eruptions are in a world of their own, and not like land volcanic eruptions, because the majority of land eruptions are, or volcanoes that are in eruption, are on or around about the equatorial line or just slightly above it. There is more activity over Africa going towards Russia right now than anywhere else in the world with regards to active erupting volcanoes on land. But as you can see, it is not the case for Atlantic Ridge volcanoes, and it's a lot more difficult to detect whether they're in eruption or not, because they are deep down in the Earth's oceans. So it is the only thing available to here is just on best theory and best guess based on logicness is the only tool that we have in this arena if we're to find out what is taking place with the South Atlantic anomaly. But just above these two regions of the South Atlantic anomaly, those two circles, you will see active ridge volcanoes. And if we look on the magnetic chart, that is a region where it just stops that blue intensity being a complete circle. And I'm just wondering if it's because of the active volcanoes. And if the South Atlantic anomaly is about to split, is it because of the active volcanoes, or the inferred vents are becoming active? What would answer this question is if we could go out to those inferred vents and find out if they're active or inactive. If they're inactive, then it stands to chance that the reason why the South Atlantic anomaly over the last decade has begun to show signs of separating and breaking into two pieces, and that could give us some good insight as to what more is about to happen during this magnetic reversal. It is a shame we don't raise much more money, and I can only be thankful at this point for what we do raise, but guys, it is always a struggle, and there is only a limit as to what one person can do. We really need to start raising some funds for this observatory, because I believe we can do a lot more than what some of these bigger organisations are doing, simply because of the enthusiasm that I've got, and a lot of you guys that are out there that chip in and help fund it have got as well. And not only that, you realise the full implications of what the magnetic poles are doing on our planet with regards to the climate that we're experiencing right now. It is down to a weakened magnetosphere. It is also down to a grand solar minimum coinciding in alongside each other, and we know what the grand solar minimum does. It shrinks the heliosphere, which is our secondary protective, and in turn, as a result of the magnetosphere reducing, our primary protection against cosmic radiation is at threat. And you know what, guys, we are in a time right now, if we go back to the earth the land volcanoes, which I'll just go and show you. If we look at that, we will see that in the last 2 years there has been 1/3 reduction in the volcanic eruptions. So, you know, this is not, in my view, times for us to, you know, pull back the reins on funding what we do. I think it's more the case to increase the funding what we're doing. We need to do more. Time is running out, and you know, we can only do what we have with the affordability of what we've got. Let's have a look at those land volcanoes just to finish off. So as you can see, there's roughly, in eruption, around 21 volcanoes. There's always one you can't see, which is in Antarctica, which is always erupting. But you know, in order for me to get that down there, sometimes we have interference with you know, the version of Windows I'm running and it not being able to cope with the rendering. But you know, this is what worries me. I'm always thinking about this, guys. This is why I'm so enthusiastic about this. You know, when you start seeing 1/3 of the volcanoes drop off in numbers over a period of 2 years, and then you add into the fact that we're overdue a magnetic reversal by 500,000 years, and you know also what happened to one of our planets, our neighbouring planets for the matter, Mars, as a result of its volcanic activity stopping, its core solidifying and its magnetosphere deteriorating. Well, you know, you have to accept the fact that this could be something happening here on our Earth. It's not uncommon because we've seen it happen on another planet, and if that is the case, you know, we could be looking at what a lot of these people talk about through various other anomalies like meteor impacts, near Earth planets coming into our solar system, stuff like that. We're talking about ELI events, extinction level events, and you know, the magnetosphere collapses completely on our Earth and doesn't recover as a result of core solidification like it did on Mars. Then everything across the biodiversity is dead on our planet. First of all, our atmosphere will be subject to sputtering, which is stripping off or ionisation of our upper atmosphere, and then once we lose that, it's just a matter of time before we lose the water on our surface. That is exactly what took place on Mars, and it is not unacceptable to think that it cannot happen elsewhere in our solar system and even on our own planet as a result of that. And that's why I'm so enthusiastic, because I really hope I'm wrong. I really hope that there's nothing to worry about but what we're seeing, but you know, we are starting to see the stages of something that occurred on our neighbouring planet take place on ours. And you know, for all I know, all these other organisations of scientific expertise seem to be missing a very important fact, that this is one of the rarest anomalies that is taking place right now in our time, and it's not even hitting mainstream media enough as what it should be. In my view, this is more important than COVID-19. Trust me, viruses have come and gone, and just look at the money that has been poured into that. How much money has been poured into this subject? Not clearly even enough. Guys, you know, we'll continue in this investigation looking into volcanic activity underwater and on land, and you know, we will find out whether those mid-Atlantic and South Atlantic ridge volcanoes are active or not. At some point we will find that information, and it will just open up more avenues of investigation for us, and hopefully we will be moving closer to the truth as to what is taking place. And let's hope we don't run out of time before we get there. Let's hope we can work out safe places to be during these periods of times where things like this happen. But if it is the worst case scenario, there's not a lot that any of us can do. But I don't like leaving it on such a pessimistic outlook. Like, you know, we have to think positive. We do have excursions. We're not sure whether this is an excursion, but one thing for sure is it is starting to get a little bit scary, watching these volcanoes on land drop off. It would be great if we could get more information as to the activity of those other volcanoes that are under the oceans as to whether they are dropping off too. So guys, I'm going to leave it here. There's a link down there, you know, please consider supporting us, what we're doing here. There's a massive effort going in, and it requires a lot of work. Just putting this video together for you guys, researching the correct maps to show you, has taken time. Some of the stuff we've got on the website and other stuff we have to, you know, search out for you, and you don't always find it first off. I mean, there are billions of pages of information on the web. To find the right one isn't always easy. So I'll leave it there, guys. There is a link down there. You can become one of our patrons. I have noticed, by the way, a couple more patrons joining us. Thank you, guys. And if we could just boost a little bit more activity on PayPal, you know, that'd be great. But there you go, guys. I'll say what I usually do. You take care of your loved ones. We'll be back probably tomorrow or Wednesday with the Earth Health at a Glance. And until then, you be safe. As always, bye for now.